So let's have a look at AQA's Practice Set 1 Paper 2, which is a calculator paper, so maybe more favourable to you, but we'll see. Bear in mind when you watch a video you don't need to watch every single question. It may just be a few questions you want to recap or check how you did on. If that's the case, just look into the video description of the comments I've made, in which you can click on to the individual question links, so you can skip out the bits of the video you don't want and go straight to the bits of the video that you do. So, without further ado, let's have a look at the first question. The first question asks us about how many grams there are in 2.5 kilograms, and we have to circle our answer. So, this question, we just need to know one fact, and then it becomes very easy. That fact we need to know is how many grams make a kilogram, and the answer to that is that that's 1,000 grams in a kilogram. And when we have a conversion relationship where one of the numbers is a 1, the other number is anything but 1, we convert from one unit to the other by multiplying or dividing by the number that isn't 1. So to change from grams to kilograms, we're either going to have to multiply or divide by 1,000. The kilogram number is small, it's 1. The gram number will always be bigger. So what we need to do is to multiply by 1,000 to change from kilograms to grams. How many kilograms do we have? It's 2.5. So all we need to do is just to type this value into our calculator, or otherwise, 2 up here. So 2.5 multiplied by 1,000 gives us 2,500. And so our first answer is to circle 2,500, and we're ready to go forward. Question 2. Which of these values can be written as A over B? Well, any fraction will always mean the top number divided by the bottom number. And so really, this should be very straightforward if you've done your revision. A over B means A divided by B. But what I'm going to do in this video, and for questions generally, is to try and give you a few fail-safes if you do have a little issue in the exam where you panic or you forget something obvious. It's a calculator paper, so you can pick just any two numbers just to try out what A over B might be. So try, I don't know, A equals 2 and B equals 10. And see which one matches up. As long as you remember you've got a calculator and there's no need to panic, you'll be absolutely fine. So if A was 2 and B was 10, they could be anything. I'm just saying pick some random values. 2 over 10 would be 1 over 5, or 0.2. B divided by A would be 10 divided by 2, which should be 5. Clearly not the same thing. What I'm saying is the only one that would match up to what we had before, which is 1/5 and 0.2, would be A divided by B. And so we can use our calculator just to double check what we should really already know. Anyway, my quick point is it's A divided by B, so let's move on. Question 3, solve 12x equals 3. So this is the equation we need to solve. If this were a class regarding solving equations, I'd probably mention it in terms of swapping side and swapping sign. That 12 is multiplying the x, so if we swap the 12 to the other side, we'll swap the side and swap the sign. So x would be 3 divided by 12, which your calculator would tell you is 1/4. If you don't believe me, I'll just quickly show you. 3 divided by 12 equals 1/4. Again, just in case you did have a panic or you didn't know what was the thing to do, you can just try all these different values for x. As long as you know that 12x means 12 multiplied by x, you can just try it and see which value works. So if x were a quarter, 12x would mean 12 multiplied by a quarter, which does give the answer of 3, which is what we need it to be. And so x equals to a quarter works. Question 4. What is the value of a digit in 3.72? So 3.72 we can think of in a couple of different ways. So in terms of units, tenths and hundreds, you can think of it like this. So 3, that represents 3 units. After the decimal, we have tenths, and beyond tenths we have hundredths, I should say. So the 7, this one, is in the tenths column, and so the 7 will represent 7 tenths. So this is where we need to circle 7 tenths. Another way you can think about it, 3.72, is to think about it as its components added together. So 3.72 you could create by adding 3 to 0.7 to 0.02. So there I've just thought about it broken down into its components. So we've got the 7, we've got the 3, and we've got the 2. 3 means 3 units, which is written like this. The 7 here, make sure it lines up with a decimal, that must mean 0.7. And the 2, because it's 2 places after the decimal, ignore all the other units, all the other numbers, leave a 2 in, change everything else to a 0, 0.02. And so in this way you can establish that the 7 means 0.7, type it into your calculator, press equals 7 tenths. Question 5. List all the factors of 18. Well, factors, we need to remember what factors mean. Factors divide into the number or into the value with no remainder. So because we've got a calculator, this should be straightforward, because if you're not sure if it will divide without a remainder or not, you can just try it. Also, as well, factors will always come in pairs. So think, what's the smallest number we can divide 18 by? The smallest number we can divide anything by is 1. Anything divided by 1 equals itself. The next one, 18 divided by 2, gives us 9. And 18 divided by 3 equals 6. And so these are all the factors. I'm just going to highlight the pairs they've come in. So 1 and 18, 2 and 9, 3 and 6. Another way you can find factors is to be thinking, what whole numbers can I find which, when I multiply them together, give me the number I want? 1 times 18 is 18, 2 multiplied by 9 is 18, and of course 3 multiplied by 6 is 18. So the last thing we need to do is to write these down on our answer line. We have 1, 2, 3, 6, 9, and finally 18. A common mistake is people sometimes forget the number itself is always going to be a factor of itself. And so always include the number itself. The number itself is always a factor of itself and a multiple of itself too. Question 6. A hotel charges £50 per night for a room, £6.95 for breakfast, and £12.50 for an evening meal. So Liz stays at the hotel for 5 nights. She has 3 breakfasts and 1 evening meal. How much does she pay altogether? What I'd suggest is just to underline or highlight the information we need. So let's see what she's doing, Liz. She's staying at the hotel for 5 nights. So she needs 5 nights of accommodation, which is this value here. And so if she's staying at the hotel for 5 nights, the total cost for the accommodation alone will be 59 multiplied by 5. Let's try this. 59 multiplied by 5 gives us 295. So if staying for 5 nights, that's going to cost her £295. But of course she's a lady of luxury, she's going to also have 3 breakfasts. Now each breakfast is £6.95. So the total for 3 breakfasts will be £6.95 multiplied by 3, because she's having 3 breakfasts. So £6.95 multiplied by 3, just check this on our calculator to be sure, £20.85. And the final thing it mentions is that she also has an evening meal. She only has 1 evening meal, which costs her £12.50. So that's £12.50 multiplied by 1. We can just leave it as £12.50. So there's the cost for the evening meal, and the middle one was a cost for her breakfast. So the final thing to do is asking for how much she pays altogether. Altogether just means we need to find the total now. So anything left for us to do is to add up these values. So 295 plus £20.85 plus £12.50 brings us to a grand total of £328.25. And so that's what we need to write down on our answer line. And then we're done for question 6. Question 7. We've got a line graph for the number of goals scored by a hockey team, and we're asked which number of goals is the mode. Well, mode means the most common value. And so which number of goals were scored most commonly? So mode just means the most frequent. So if they scored no goals in only a couple of matches, they've never scored 5 goals, so that certainly isn't the mode. So what's the most common number of goals they scored? It's 3 goals actually, because they scored that in 6 matches, which is more than any other number of matches for any other number of goals scored. So the mode number of goals is 3. part B, how many matches did the hockey team play all together? So we're told here how many different games they've played, because we can have a look at the total number of matches. And so number of matches where they scored 0 goals is 2. So that's 2 matches indicated here. How many matches did they score 1 goal for? That was 5. Just checking the heights of the bars. 2 goals they scored in 4 matches. 3 goals in 6 matches. 4 goals in 2 matches. We've never scored 5 goals in a match. And 6 goals they scored in 1 match. So we can total up all these numbers of matches here to find our grand total. So all we're doing is just totaling these numbers. So we're doing 2 plus 5 plus 4 plus 6 plus 2. You could say plus 0 if you really wanted to, but I'm going to leave that out. Plus 1. So if we add up all these on our calculator, we get 20 goals exactly. So the final answer for part B is 20 goals. Now in part C, we're told in one of the matches the team won by 5 goals. What was the score in that match? So this is some slight logical thinking really. They won by 5 goals. If a team wins by 5 goals, that means they must have scored at least 5 goals. There's no other way they can do it. You can't have won by 5 goals and only scored 4. It just doesn't make any sense. So using this bit of information, that means they must have scored at least 5 goals. It doesn't mean they have to have scored exactly 5 goals. They could have scored 10 and conceded 5. But if the score was 10-5, overall that's a win of 5 goals, because 10 minus 5 is 5. So could they have scored 5 goals exactly and it been 5-0? Well, no, because they never had a match where they scored 5 goals. And so the only other alternative is they must have scored 6 goals. But if they scored 6 goals and it was 6-0, they would have won by 6 goals, not by 5 like it's saying. So the other team must have scored 1 against them. So the score must have been 6-1. Because 6 take away 1 is 5, like we need it to be. So the score must have been 6-1 for that match. Question 8. The game is played with a fair spinner. The player spins the spinner twice, and the score is the difference between the 2 numbers. Complete the table to show the scores. So, importantly, we're not going to be adding up the scores for this one. What we're going to be doing is finding the difference between the scores. Difference just means one taken away from the other, but difference isn't going to be negative. And so if the 2 scores on spinner 1 and the second spin were both a 1, that means the scores weren't different at all. So if the difference was nothing, that'd just be a 0. This one, if it was a 2 and a 1, 2 take 1 is 1, 4 take away 1 is 3. And so if we complete the table in the same way, that's a difference of 1. If they both got 2, that's no difference. This one would be a 1, and 4 take away 2 would be 2. If the second spin was a 3 and the first was a 1, 3 take 1 is 2. 3 take away 2 is 1, that's 0. And this one would be 1. because 3 is 1 bigger than 3. And finally, for the final row, it would be 3, 2, 1 and 0. And so you should find, hopefully, that your values will agree. If not, just thinking of what's the difference between the first spin and the second spin, and make sure that your answer is put in as a positive number. So that's the one for part A. Now for part B, we've got some more information about what we've just filled in. So I'm just going to quickly scribble down the results from the previous page. I'm just making an exact copy of what I've done before. So I'm not working anything new out here. I'm just making a copy of the table from part A. So now we can use this information to help us for part B. It says a player loses if the score is a 0 or a 1. And so let's see how many would result in a loss. How many combinations would result in a loss? So we're just finding all of the 0s or 1s and highlighting them. The second thing is it says the player wins if the score's a 2 or a 3. So some combinations allow the player to win. Amy says 2 scores win and 2 scores lose. So what she means by that is the winning scores are 2 and 3. And the 2 losing scores are 0 or 1. And she's saying because of that the chance of winning is evens. Is Amy correct? Tick a box. It's tempting to go for she's correct because 2 and 3 are 2 numbers. 0 and 1 are 2 numbers as well. The way I'd think about this is if you had a dice with just 2 numbers, a 5 and a 6, if 5 sides were a 5 and only one side was a 6, surely it'd be more likely to roll a 5 than a 6. Even though there being 1 5 and 1 6, there's one of each number. So it's not quite as simple as what she's making out. What we need to consider is the total combinations. Ultimately, she's not right. And this table here explains why. If we have a look here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 combinations. There are 10 ways to lose, but only 6 ways to win. The 10 ways to lose, talking about these values here, and the 6 ways to win are these 6 values are highlighted in the table. So because of that, so losing is actually more likely. So it's not an even chance. We're actually far more likely to lose rather than win. Question 9. We've got a drink is mixed in a ratio lemon, orange and cranberry in the ratio 6 to 3 to 2. So if we inspect this a bit fuller, lemonade consists of 6 parts. The orange is 3 parts. Cranberry is 2 parts. The order the things I mentioned in the question is the same as the order the numbers appear in the ratio. And so the drink is the total of parts, because the parts are mixed together to make the drink. So the drink they're making That means the total of parts. Which is 6 plus 3 plus 2. So the drink consists of 11 measures, or 11 parts, if you like, 11 equal parts. 6 measures of lemonade plus 3 measures of orange plus 2 measures of cranberry makes the drink. And so the drink is out of a total of 11 parts. Which appears here. We're asked what fraction is orange. That means what fraction of the drink is orange. And so the orange is 3 parts out of a total of 11. Orange is the middle value, so 3. The total is 11. So the orange fraction is 3 out of 11, which we put into a fraction like this. And so the fraction we need to be circling is 3 out of 11. Question 10, we've got a massive pylon to be looking at. The crucial information for this question is that it's drawn to scale. So it's so big I couldn't even fit it onto this page. The main thing is the diagram's drawn to scale, and what we've got down here, if we just scroll down, a man who looks tiny in comparison, and we have to use the height of a man to estimate the height of a pylon. Okay, so what we need to do is think how many times bigger is the pylon compared to the man. But the question does say estimate, so don't stress it too much. Having said that, do measure as accurately as you can. So what we're going to need to use for this question is a ruler. Okay, so using the ruler, what we'll need to do is measure the height of the man. So if I just get this ruler, bring it down to meet the man, as it were, get it right against him. That looks to be, or should look to you, to be roughly 15 millimeters. You could say 1.5 centimeters if you'd prefer. So I'm going to say the man is approximately 15 millimeters on this diagram. Now on this diagram as well, let's find the height of a pylon. So start from 0, and measure all the way going to the top. So the pylon ends here. So that looks to be that's 17 centimeters, 17.5, 17.6, between 7 and 8 extra millimeters. So the height of the pylon, I'd be saying, is roughly 178 millimeters on our page. So we've measured that with a ruler, so now we can say the pylon is about 178 millimeters tall on the diagram. Obviously a real pylon is significantly bigger than 178 millimeters. They'd be really tiny, and that'd be weird. So now we need to think how many times bigger is the pylon than the man. And what we can do is 178 divided by 15, or your measurement of a pylon divided by your measurement of a man. I'm hoping you found similar measurements, by the way, on your diagrams. If you're out by half a millimeter or a couple, that's probably nothing to worry about. That might be even because of different photocopier settings at your college or what your teacher's done. It could also be that the diagram's been resized. But the important thing you should all agree on with me is the ratio of the height of a pylon to the height of a man. 17.8 divided by 15, 11.86. Now that is roughly 12 times bigger. Because it says estimate, we're allowed to round off with this one. So the pylon is about 12 times bigger than the man. You could have used 11.86 and kept it as accurate as you wanted if you'd prefer, and that's okay, because by the nature of this question, it is an estimation anyway, because there's going to be some natural error in how accurately we're measuring. Also as well, for all we know, he might be standing on tippy toes or have a massive hairdo. He might have his hair really spiky, he might only be 14.9 millimeters. So we're forced into it being an estimate no matter what we do. But because it is an estimate, you can take that as a free license to round your values as long as you're rounding sensibly. So the man is about 12 times bigger than the pylon. No, the pylon is about 12 times bigger than the man. That would be ridiculous. What I've done is I've just tried to show you how you can picture it. If you imagine this was some sort of crazy circus, with him just stacked on top of himself in some sort of crazy cloning device. It'd have to stack up about 12 of himself to be as tall as the pylon. So let's count them up. That's 1, 2, 3, 4, 5, 6, 7, 8. Scroll down. 9, 10, 11, 12. So hopefully you can use that idea. Obviously you can't replicate that on your exam paper, but that hopefully makes it a bit clearer that the pylon's 12 times as big as a man. And so what's the actual height of this man? Luckily, we've been told he's 1.8 meters tall. And so what that'll mean is a pylon will be 12 times as tall as a man's actual height. So 12 multiplied by 1.8, or if you really wanted to, 11.86 multiplied by 1.8. What your calculator should be telling you is that the man being 1.8 makes the pylon approximately 21.6 meters high. So the answer would be 21.6 meters. Do bear in mind that your answer needs to be sensible. Pylons are the things that carry electricity. You see them in fields and things, they're pretty damn high with massive wires going across them. If you're getting an answer of, say, less than a meter, alarm bells need to be ringing. So always try to relate, if you can, the answer to real life. 21.6 is pretty tall, so that might well be true. In fact, that would be the most sensible answer for this question. Question 11. Compute the table for y equals 3x plus 1. And so what this means in plain English is whatever x is, y is going to be 3 multiplied by that with 1 added on at the end. Because this is a calculator paper, we can use the calculator to help us quite a lot here. So what we could do, first of all, is just try the different values of x and substitute these into our calculator. So for example, when y is minus 2, sorry, when x is minus 2, I mean, y is always 3 multiplied by whatever x is, in this case minus 2, then always plus 1. So for this one we'd have minus 5. When x is 0, we're going to do 3 multiplied by 0 plus 1, which is 1. When x is 2, 3 times 2 plus 1 is 7, as your calculator would show. And finally, with or without your calculator, when x is 3, y will be 3 times 3 plus 1, which is 10. So, if you notice here, each value is increasing by 3 each time. So the y values are going up in 3s each and every time. The gap between the y values is 3, and that's no coincidence. I'm mentioning this because this pattern helps if it were, for example, a non-calculator paper. If a formula is in the equation y equals mx plus c, we've got 1y equals so many x's plus or minus another number. The number in front of the x, in this case for 3, will always tell us what the y values are going to be increasing by. So it's worth knowing that pattern anyway, just in case. So that's the completed table. Part B, we need to use that completed table to actually draw the graph of y equals 3x plus 1. So just borrowing what we had from before, these are the values from part A, I'm just filling them in quickly. So we need to draw that graph for values of x from minus 3 all the way to 3. Now, if you're comfortable with the fact that all you need for a straight line graph is just any 2 points, what you could do is just plot the first one, which is minus 3 and minus 8, and the last one, which is 3 and 10, and do a straight line between them. So minus 3, minus 8, with this point here, and 3 and 10 would mean x is 3 along, y is 10 up, which is this point here. But in the exam, obviously not going to have the luxury of just highlighting everything, so what you could do, what I suggest you do, is just to put a cross over each point. It never hurts, by the way, to do a cross over every single other point. But if you wanted to save some time, you could just pick 2 points and draw a line straight through them. So a line straight through these points. I'll try and get that a bit more accurate, in fact. Would be that. Now, what it's sometimes worth doing is just plotting the other points anyway, because all the points will lie exactly on the line. It's not a scatter graph where some might be away from the line. If any points aren't exactly on the line, that can help you to highlight which one of these values in the table you may have got wrong. So minus 2 and minus 5 is perfectly on the line, as we'd hope. Minus 1 and minus 2, that again is perfectly on the line. 0 and 1. 1 and 4. Is here. And 2 and 7. So, unfortunately all our points are on the line, and so we're done. For drawing the line at least. I've actually made a slight highlighting error. That 3 and 10 I meant to highlight with green. That makes slightly more sense now. Now we're told to solve x equals 3x plus 1. Now there's 2 ways I'm going to show you for this. Graphs can be used to show where equations are equal. So what I've done here is the graph of y equals 3x plus 1, which is this line which we've just drawn. What we could do next is to draw the graph of y equals x. And where these two meet will actually show us where 3x plus 1 equals x. And so if we were to draw the graph of y equals x and see how it crosses the graph we've already drawn, that would solve for us the equation where x is equal to 3x plus 1, because where one is equal to the other is where the lines would cross over. And so what we can do is the line of y equals x, so we can just pick any points where x and y are exactly the same as each other. So x and y are always going to be exactly the same. So for example, if x was 4, y would be 4. When x is minus 4, y would be minus 4. And so for this line, we just need to do a straight line from this point through to the other one. So what we've got now is two lines. The first line we drew was the equation of y equals 3x plus 1. This one over here. And the one I've just drawn now is y equals x, which is this straight line, which is slightly not as steep. So where do they cross over, I wonder? They cross over here, that red dot. That's between x being 0 and minus 1. Between 0 and minus 1 is minus a half. X would have to be minus a half. So we can do two graphs, see where they cross, and the intersection, where the graphs cross over, that tells us the solution of the equation. I'll just mention another way as well, which doesn't involve drawing a graph at all. This way is just purely using algebra. So if we set out our equation like this, just using algebra, to solve an equation where we have unknowns on each side, what we need to do is have all the unknowns together and all the units on the other side. So what we could do first of all is take this x over here to join the 3x. But if we swap side, we swap sign. So this x will become a minus when we move it. Another way you can think of this is we're just subtracting an x from each side. So when we subtract an x from this side, we've got nothing left. We need to do the same over here. So 3x take away x would leave us with only 2 x's, and then plus 1. Now we want to have that number on its own on the other side. So we need to shift this plus 1 over in the same way. So if we swap side, we swap sign again to a minus. So on this side we'd have 0 take away 1, which should be minus 1, equals 2x. And finally, we can just divide both sides by 2. We get minus 1 over 2. And so there are two ways of doing that question. Personally, I prefer the algebra way because it takes the guesswork out of guessing whereabouts your lines cross, but each to their own. And one answer backs up the other, hopefully. So it's worth knowing both answers and both methods. Question 12. Jodie's pay is £315 per week, and she works for 37.5 hours per week. Now, I need to work out her hourly rate of pay. So I'm going to use this as an opportunity to show you how you can use the mixed number function on your calculator. The calculation to work out her hourly rate of pay would be 315 divided by 37.5. So I'll show you now how to do that. It's not this, by the way. We don't just type in a half and press back and type 37 in front of it. It looks tempting. That looks the same, doesn't it? But if you press equals 37 and a half, that's not 18 and a half, that's something completely different. What you need is a mixed number button, which I'm going to show you now. So we do 315 divided by, and then we press shift, and if you look at this function here, that allows us to type in mixed numbers. So 37 and a half, and press equals 8.4. That represents £8.40. So her hourly rate of pay is £8.40. If what I've just showed you freaks you out slightly, or you think, well, I might forget how to do mixed numbers, it's always worth remembering what half is as a decimal. As a decimal, half means 0.5, so 37 and a half in decimal form would just mean 37.5. So if you're more comfortable using the decimal form of a number, we could do that calculation instead. 315 divided by 37.5 comes to £8.40 again, as you'd expect it to. Part B, Jodie wants to work out her yearly pay. And what she says is there's 4 weeks in a month, so she's going to multiply 315 by 4 to find her monthly pay. Secondly, because there's 12 months in a year, she's going to then multiply that by 12. So that's her calculation here. Let's see first of all if her calculation, what she's done, rings true. Well, that seems true. So if her method isn't correct, it's not because of an arithmetic error. Her numbers here do actually come to what they should. And so if there's a mistake in her method, it's not from her math skills, it's from the logic she's used. So let's just check out what she's saying to make sure it makes perfect sense. So 315 is her pay per week. Now, in a year, I would say it's important for you now to be knowing that there's 52 weeks in a year. You really need to know that. 52 weeks in a year. So what you could do is think about, well, how would I work out her yearly pay? What I'd suggest doing is just 315 multiplied by how many weeks there is in a year. So 315 multiplied by 52. Let's see what that gives us. £16,380. So that's what she'd actually get paid. So actually her yearly pay would be more. What she's done by multiplying by 4 and multiplying by 12 is she's multiplied 315 by 48, because 4 times 12 is 48. So she's a few weeks short. The reason why she's made the error is she said there's 4 weeks in a month. Now 4 weeks is 28 days, so it's roughly right, but almost all months have a bit more than 28 days. The only month with exactly 28 days is February, but even then, on a leap year, February have 29 days, so almost all the time a month is going to be a bit more than 28 days. So that's why what she's done is a underestimate. So that's why she's not quite right in this case. To make sure to tick that box that her yearly pay would be more. Question 13. A cube has edges of length 0.8 meters. Work out its volume in cubic centimeters. First of all, before we worry about volume, let's just check the units. these units here are in meters. 0.8 meters by 0.8 meters by 0.8 meters. But we want our final answer to involve centimeters. So what I would suggest first and foremost is to convert straight away. And so you need to know that 1 meter is 100 centimeters. Again, this is a conversion relationship where not one number is a 1, the other number isn't a 1. So if we were changing from one to the other, we're either going to multiply or divide by the number that isn't the 1. In this case, the number that isn't the 1 is the 100. And so if we're changing from meters to centimeters, we're going from a small number to a bigger looking number. So that's timesing by 100. Let's go the other way. From a biggish number to a smallish number, we're going to be dividing by 100. But in this case, we're wanting our answer in centimeters. So we want to change away from meters into centimeters. And so to do that, we're going to be multiplying by 100. So 0.8 of a meter, multiply that by 100. We'll get 80 centimeters. And so the measurements of this cube in centimeters will be 80 centimeters by 80 centimeters by 80 centimeters. Now we've changed into centimeters, we can just process the volume. The volume of a cube, or cuboid, is just the length multiplied by the width multiplied by the height. So it's length times width times height. So because it's a cube, all these values will be the same. 80 times 80 times 80. We want centimeters out, so we put centimeters in. So we're not going to use 0.8, we're going to use 80. The units we put in relate directly to the units we get out. So 80 times 80 times 80. Now that means literally 80 cubed. 80 cubed. Cubed is a cube, that's not a coincidence. So 80 cubed we can just do here by 80, and there's a special cube button on your calculator to the power of 3. We get 512,000 as our answer. So in cubic centimeters, the volume of this shape is 512,000. And that's it for question 13. Question 14. We've got 3 whole numbers with a total of 100. The first number is a multiple of 15. The second number is 10 times the third number. Work out the 3 numbers. This is a real sort of where do I begin type of question. What I'd suggest, to be honest, is a case of systematic trial and improvement, just based on the information we've been given. So what I'd suggest is to do or think of some sort of system for tabulating different possibilities of what the first number could be, what the second one could be, and what the third number could be. Multiples of 15 could be anything, but the good thing is we're limited by the total being 100 and at the whole numbers. So as long as you can see this as the fact that you wouldn't be guessing forever, that should be some sort of relief. And again, for a question with multiple marks, in this case I think it's a 3-mark question, it's well worth just taking the time to work out what it could be. So question 14, if we have a look here, it says the second number is 10 times the third number. So whatever the third number is, we'll have to multiply that by 10 to work out what the second one is. So that could actually be our starting point. Based on the fact that we know these numbers have to be whole numbers, what's the smallest first whole number? It would have to be 1. If the third number was 1, the second number would have to be 10. If the third number was 2, the second number would have to be 20. If the third was 3, that would have to be 30, and so on. So we've got at least a starting point now. 5 and 50, 6 and 60, 7 and 70, 8 and 80, and so on and so on. But just remember, if you went up to 9 and 90, that would give a total of the second and third of 99. Because the total of the numbers has to equal 100, that would mean the first number would have to be 1, which is obviously impossible. Once you know that the total has to add up to 100, the first number we can work out by doing 100 minus the first number minus the second number, and just seeing what it is. The only thing about the first number is it's got to be a multiple of 15. It's got to be in the 15 times table, but we can try that out after. So just looking here at the first row, if the third number was 1, the second number would be 10. So 100 take away 10 take away 1, which should be 89. Is 89 in the 15 times table? Let's see if it goes into 15. No. So this one, 100 take away 10 take away 1 equals 89. Is that in the 15 times table? No. So that's a no. But let's just try again. If the third and second were 2 and 20, the first number would have to be whatever's left to make it to 100. So 100 take away 20 take away 2 is 78. Now is 78 15 multiplied by something? It's not, because that's not a whole number. And so what do we have as our answer? It was 78. Is that a multiple of 15? No, it isn't. If you'd prefer to have a list of the multiples of 15 first, you could do. So you just know exactly what you're looking out for in advance. So multiples of 15, your 15 times table will be 15, 30, 45, 60, 75, 90, 105, and so on. But of course, because the total of these numbers has to be 100, we can rule this one out straight away. So we know it's got to be one of these possible options. So let's look out for it when it comes up. So we've tried two options, two combinations, they've not worked. The third combination, if the third number was 3 and the second was 30, that would leave the first number having to be 100 take away 30 take away 3, which should be 67. Now is 67 in this list? No, it's not. Let's carry on and try another combination. Maybe it's this one here. So if the second number was 40 and the third number was 4, that means the first number would have to be 56, so that all the numbers add up to 100 like they need to. So that would work, but only yet again, 56 isn't a multiple of 15, so no luck so far. But just stick with it, keep going. The next one. If the third number was 5, the second number was 50, the first number would have to be 100 take away 50 take away 5, which should be 45. Now 45 is in there, so yes, that works. So now we can stop trying the other numbers. We know it's got to be 45 for your first number. That's 3 times 15. The third number would be 5. And the second number, 10 times a third, 5 times 50. Sorry, 5 times 10 is 50. And as a double check on your calculator, do these add up to 100? And they certainly will. 45 plus 50 plus 5 equals 100. So the key to these questions is not to panic and just think, how can I be systematic? How can I just start off somewhere? The hardest thing with these ones is knowing how to start off. But try anything to get started, then improve from your first guess. Question 15. In March, Kim pays the same amount for each song she downloads. So it says she pays £35.60 for 40 songs. So looking at this one here, the first bit of information is for March. So in March, she paid £35.60 for 40 songs. So how much would that be per song, I wonder? So in March, we can calculate how much she paid per song by calculating the total price divided by how many songs she purchased. So £35.60 divided by 40. That gives a total of 0.89. So it's 89 pence a song she paid in March. It says in April, she pays 5p more for each song. So for April, she'll pay 5 pence more than what she paid in March for each one. So for April, that'll be 0.89 plus an extra 5 pence. We could do 89p plus 5p, which would be 94 pence per song. So it's gone up by 5 pence to 94 pence. So in April, it's now 94 pence per song. She has a £30 voucher. What's the maximum number of songs she can download using the voucher? So £30 in total is what she's got to spend using the voucher. So it's how many lots of 94p can she milk out of a £30 voucher? So it's going to be £30 divided by 0.94. So 30 divided by 0.94 comes to 31.9 something. So 31 songs, 31 complete songs with a bit of a song left over. So she can't quite afford 32. So she can only actually afford a total of 31 songs. And that's our final answer. I was going to mention, if you weren't sure that it was a divide, if you could get to this stage and find it was 94 pence per song, you could just do a trial and error. I'm not recommending this unless you really aren't sure what you're doing really, but just in case, you could just try 94 pence multiplied by different values. So 25 songs would be 94p times 25. Can she afford that? Yeah, that's only £23.50. Try 26. £24.44. She can afford that. 27. That's less than £30, so that's affordable. And just keep trying and keep trying to get as close to £30 as you can without going over. 28 songs, again that's okay, because it's less than 30. 29 songs is £27.26, she can afford that. If we multiplied by 30, £28.20, again she could afford that. £29.14 for 31 songs, again that's okay. Can she afford 32 songs though? That's £30 and 8p, so that's 8p over. So she can't quite afford 32 songs. I'm just trying to illustrate there how if you weren't sure that it was a division straight away, for example if you had a bit of a stress or a panic in an exam condition, this is just another workaround solution you might want to consider trying. Question 16. Circle the vector that translates shape R to shape S. Now, with vectors, we have a top number and a bottom number. So, what you need to remember for vectors, the top number tells you how far it's moved to the right. The bottom number tells you how far the shape's moved up. So that means how far up. So if we have a look here at this vector, or this shape, from R to S means it's gone from here to here. So what we can do is pick any point, in fact, on the shape. So if we have a look at that top right corner, it's moved to there. So how many squares along has it moved? So from here to here, how many has it gone across? It's gone 1, 2, 3, 4, 5, 6 across. So it's actually moved 6 right. But then it's gone slightly down after. So it's gone down 1 square to here. So 6 right and 1 down. So using the format of vectors what I've mentioned before, so the top number means how far it's moved to the right. It's moved 6 to the right. The bottom number, how far it's moved up. Well, it's moved 1 down. So opposite of moving up is moving down. So because it's gone 1 down, it wouldn't be 1, but it would be -1. And so the answer for our column vector that describes the translation is 6 and -1. So we need to find that on our possible lists of answers to circle, and it is here, 6 minus 1. Question 17. How long is side AB? Don't go measuring it because yet again it says it's not drawn accurately. So if you know 2 sides and you want to find the third side, what you could do is realise it's going to have to be Pythagoras' theorem. And so x squared is going to equal 5 squared plus 8 squared. Remember with Pythagoras, the big side squared equals the smaller side squared added to the other small side squared. So we can add these together. 5 squared plus 8 squared. We get 89. So x squared equals 89. The final step with Pythagoras is always to take the square root. So the square root of 89 is about 9.4. So we'd know to tick between 8 and 13, because 9.4 is between 8 and 13. If you weren't sure about Pythagoras, or yet again you may have had a mind blank or not too sure, just be thinking what you do know. It's a right angled triangle, so try and remember that the side opposite to the right angle will always be the longest side. So you know that if the other sides are 5 and 8, it's got to be at least a tiny bit bigger than the other sides. So it's got to be more than 8. So if it were a case of ticking a box and going for your best guess, you definitely wouldn't be saying it's between 5 and 8. It's got to be bigger than that. And it can't be 8, because as I've said, it's got to be more than 8. So by process of elimination, you could definitely eliminate the top two boxes and be thinking it's got to be either this one, between 8 and 13, or more than 13. So that's just a way of thinking it through, so you can give yourself a better chance of guessing the right answer in a worst case scenario. Question 18. I'm thinking of a prime number. Its digits add up to a square number. Write down a prime number that I could be thinking of. So, what I'd suggest first of all is to just do a list of primes. First prime number is 2, by the way. After 2 would be 3. After 3 is 5, 7, 8 isn't, because it can be divided by 2 and 4. Just to recap, a prime number means a number that can only be divided by 2 different things. So I'm just going to highlight that. A prime number, all that means is it can only be divided by 2 different numbers. It only has 2 factors. So carrying on as I was, 8 isn't, 9 isn't, because 9 can be divided by 3. The next prime number would be 11, and 13, 17, 19, not 21 because that's in the 3 times table. The next one is 23. So that's the first few prime numbers. Really, you should know these if possible. So it says next, its digits add up to a square number. Notice it says digits plural, and so chances are we're going to be looking here for at least 2-digit number. So let's try 11. What do the digits of 11 add up to? 1 plus 1, they add up to 2. But 2 isn't a square number, so it can't be 11. But 13 is 1 and 3. Now 1 and 3 equals 4. Now that is a square number because 4 is the same as 2 squared. 4 is 2 times 2, and so it must be 13 that this person was thinking of, because 13's prime and 1 plus 3 equals 4, which is 2 squared. And so that one, they must have been thinking of 13. Unless you wanted to go on even further with your prime numbers and find another prime number where its digits add up to a square number. So moving on, we've got toilet rolls, which come in packs of 4 and 9. So what I'm going to do here is just section off a page into thinking of the pack of 4, and over here the pack of 9. we're asked about which is best value. So the pack of four rolls costs £1.89. We can work out the cost per roll by thinking, what could I divide 4 by to get down to just one roll? If we work out the cost per roll, we can compare that against the pack of 9 cost per roll. Whichever's cheapest will be best value. So per roll, to go from 4 to 1, well, any number divided by itself is 1. So what we can do here is divide by 4. And over here, £1.89 divided by 4 will tell us the cost per roll. So £1.89 divided by 4, 0.4725. If I round that to the nearest penny, pence has 2 digits after the decimal. So to the nearest penny, that would be 0.47. So each roll is going to be 0.47, about 47 pence. Now we can compare that with a pack of 9. A pack of 9 rolls cost £3.99. So in a similar way to before, what could we divide 9 by to get down to just 1? What we could do here is 9 divided by 9, because yet again, any number divided by itself will always give us 1. And so 9 rolls divided by 9 is just 1 roll. And over here, £3.99 divided by 9. To the nearest penny, that's about 44 pence. So each roll is about 44p. And so, which is cheaper? So 44 pence a roll or 47 pence per roll. So obviously the pack of 9 is slightly cheaper per roll. It's less expensive per item. And for that reason, we can say that the pack of 9 is the best value, because it's cheaper per roll. Question 20. Increase 4,200, if I can get my spectacles on, by 38%. So what we could do first of all is just simply work out what 38% of 4,200 is. Well, 38% percentage means out of 100. Of works as multiply, and type in 4,200. So if we were to just calculate 38% of 4,200, what we'd come to is 1,596. But the question isn't actually asking us for 38% of 4,200. What it's asking us for is to increase the amount by 38%. We've worked out what 38% of it is, which is 1,596. Increase means the amount's going to get bigger. So we're going to add on 38% to the original amount. So increase means we're going to add it on. Whoops. Increase means add on. We're going to add on the 38% we found before, which is 1,596. So if we add both these numbers together, 4,200 plus 1,596 596, we get 5,796. And that would be our final result, the final answer. Question 21. The table shows information about journeys A and B, and we need to complete the table. What I've included here is a speed, distance, time magic triangle. So speed, distance and time. Whatever we want to work out, we can cover up. So in this case, for A, we know the distance in miles, and we know the speed in miles per hour. So what unit of time is mentioned here? Miles isn't time, but H stands for hours. And so if we take these numbers and put them into the equation, hours in means hours will come out. So at any rate, we want to work out the time taken. So first of all, what we can do is cover up time over here. So just cover up time. What we'd have left is distance divided by speed. Time equals distance travelled divided by speed. If you're not sure it means divide, just think of it as a fraction. We've got d on top, s on the bottom. So for this one, d on top, so put 32 on top, s on the bottom, which is 64. It comes out to be half, so half an hour is what we'd have. So time taken would be half an hour. If you wanted to, you could say it's 30 minutes. Now, for part B, it's slightly more complicated. We want to work out the distance travelled. Now, distance travelled, look at the units going in. We've got hours and minutes in the time. Average speed is in miles per hour. So we need really our time to be in hours. So 1 hour 20 minutes. Just remember that there's 60 minutes in an hour. I'm going to show you two ways of doing this. 1 hour 20 minutes, we could think of that as a fraction of an hour. So 1 hour and 20 minutes is a total of 80 minutes. 80 out of 60 would give us 4/3. So that's 4/3 of an hour. So then, as I say, using this magic triangle, we want to work out the distance travelled. We know the time and we know the average speed. So cover up distance and see what's left. Got speed and time next to each other. Two things next to each other in maths with no instruction will always mean one multiplied by the other. And so the speed is 42. The time in hours is 4/3. So 42 multiplied by 4/3 is 56. And so that would be 56 miles. I did mention another way we could do this. What we could do is think about the time taken in terms of minutes. 1 hour and 20 minutes, that equals 80 minutes. And so if we did speed times time using minutes, what we would have got is the speed of 42 multiplied by 80, which would be 3,360. Obviously it's not going to be travelling 3,360 miles. That's because we use minutes in our calculation. So to go from minutes and think about how far I travel in an hour, the conversion factor is 60. So we could then divide by 60 at the end, and we get 56. So part B, definitely slightly harder than the first part, but that's how you'd complete both bits of the table for question 21. Question 22. 50 people took a test. It says before the test they predicted whether they would pass or fail, and 30 people predicted they would pass. So this is going to be our first step. 30 people predicted they would pass. And so the people who predicted they'd pass would have to go into this box here, which is 30. Now, if 30 predicted they would pass, that must mean the other 20 must have thought they'd fail. That's 20 because 50 take away 30 will equal 20. The next thing it says is that 26 people who predicted they would pass did pass. And so up here, 26%, so 26 people did think they'd pass, so we put 26 here. The key theme with the probability trees, frequency trees, sorry, is that when the tree branches into two, the two things it branches into need to add up to what it branched from. And so this one here, for example, if this is 30, these two need to add up to 32. So if this one's 26, this one will need to be 4, because 26 plus 4 gives us 30. In the same way as the first branch, these two numbers here need to add up to 50. It then says 36 people passed altogether. And so if 36 people passed altogether, we can work out how many people passed who thought they wouldn't pass, the people who predicted they'd fail, but ended up passing. So because we're told that 37 people passed altogether, the people who passed and were surprised would be 37 minus 26, which would be 11. Because 37 people did pass altogether, and we know that 26 people passed who thought they would, so the others that passed must be the remaining 11. And finally, because this is 11, and it branches from 20, these two here need to add up to 20. So 11, this must be 9, because 11 plus 9 equals 20. And then we're all done for this one. Question 23. You've got a cuboid which has been made from centimetre cubes. This has been given the plan view. Plan means what it looks like from the top looking down. A plan view means a bird's eye view. So I'm going to try and colour in roughly all these squares, which shows what the plan view would look like. So looking at it from the top downwards, we'd see these green squares. After that, it says the front elevation. The front elevation just means what it looks like if you stood straight on, looking at it from the front. And the final one, the side elevation, just means what the shape would look like from the side. Because it's a cuboid as well, we should hopefully know that the volume of a cuboid is the length multiplied by the width multiplied by the height. And so we can use these three different views to work out what the length of it, what the width would be, and what the height would be. So for example, if we look at the side elevation, sideways on, we can work out how long it is. So sideways on tells us that it's 6 centimeters wide. Each cube is a centimeter, and so because it's 6 centimeter cubed, that means 6 centimeters. 6 squares represents 6 centimeters. And the front elevation tells us how wide it is. So front elevation tells us how wide, which we can see here, is 4 centimeters because it's 4 squares wide. And both the front elevation and the side elevation show us how high it is. So how many squares high? It's 3 squares high. So the volume, which is the length multiplied by the width multiplied by the height, well, we know the length is 6, so this will equal 6. The width of it, we can tell from the front it's 4 squares wide. That's 6 times 4. Then multiplied by the height. The height is 3 centimeters. So 6 multiplied by 4 multiplied by 3 will give us our final answer. So 6 times 4 times 3 would give us 72. So the answer to this one, how big is its volume, is it's 72 cm cubed. So 72 cubes must have been made to make the shape. These plans and elevations can sometimes be quite confusing to interpret, so what I've done here is I've shown you a different way around where you could think about it. So what you could do is actually sketch out the diagram. The plan view will look like from the top, from the front, and from the side. So if you map it out, you can get a bit more of a better picture of what the shape would actually look like, and from there you may find it easier to calculate how many cubes would have to make the shape altogether. Question 24. For times 80 customers waited at a supermarket checkout as shown, and we're asked which class interval is the median in. Class interval just means which ones of these things is it in. And say if there's 80 people stood in a line, the median would be about halfway, which would be about the 40th person. It'd actually be in between the 40th and 41st, but forget that for a second. Median just means halfway along, so for a big number, it's about 40. Half of 80 is 40. And so in which class interval is the 40th person, is what it's saying. So this is the first 32 people. This is the first person up to the 32nd person. And this is the next 19 people. This is the 33rd person, all the way up to 32 plus 19, which is the 51st person. So the 40th person will be in between the 33rd and 51st somewhere. And so because of that, we know which one it contains the median. It's got to be this one here, because a median will be somewhere in between the 33rd and 51st person. So we need to circle for this one 2 crocodile T, crocodile 4. part B, the manager of a supermarket says that 90% of our customers wait less than 6 minutes. Less than 6 minutes we can highlight actually on here. Less than 6 minutes means all of these people here, because this is 6 minutes or less. The last two rows are 6 minutes or more. And so how many wait less than 60 minutes? Sorry, less than 6 minutes. Let's just total this, all this up. Got 32 plus 19 plus 20 customers waiting less than 6 minutes. And so if we add all these numbers together, 32 plus 19 plus 20, comes to 71. So 71 people. Wait less than 60 minutes. Now if there's 80 customers altogether, if a manager's saying that 90% of customers wait less than 60 minutes, but 90% of all the customers would be 90%, 90 out of 100 of all 80 customers. And because 80 customers, and the manager's claiming that 90% of them wait less than 6 minutes. So 90% of 80 is 72. So what the manager's saying is that 72 people wait less than 6 minutes, whereas actually only 71 people waited less than 6 minutes. So although he's close to being right, he's not actually right. He's one person out. 71 people waited less than 6 minutes. He's claiming one person extra with 72. So does the data support his statement? The final answer is no, it doesn't. Question 25. Thomas ran a lucky dip stall for 750 tickets numbered 1 to 750. He sold all the winning tickets and some losing tickets, and he made a profit of £163. We need to work out how many losing tickets he sold. So first of all, what we're told in this little advertisement is tickets are 50p, and for tickets ending in a 00, win £12. And tickets ending in a 5 win £1.50. So we're told that there's 750 tickets. So first of all we can think, well, how many tickets end in 00? Well, that means tickets which are 100 and something. So it could be for ticket number 100, 200, 300, 400, 500, 600, or maybe 700. There's no ticket 800, so these are the only tickets ending in 00. So there's 1, 2, 3, 4, 5, 6, 7 tickets ending in 00. So for tickets that end in 00, we've worked out there's 7 of them. Now some tickets end in a 5. Well, any number's going to end in something. So a number can either end in 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. So 5 is just one number out of 10. One digit out of 10. So 1/10 of the tickets will end in a 5. Because tickets ending in a 5, they've got to end in one of the 10 digits, and 5 is just one of those 10. So tickets ending in a 5 will be 1/10 of 750, which would be 75 tickets. Wrong colour. Yet again, wrong colour. Not a good day. Anyway, tickets ending in a 5, 75. So, what we can work out now is how much customers won. So, total customer winnings. Even if you weren't sure on the first step of how many tickets ended in a 5, make up a number. Seriously, make something up so that you can then continue with that number and work out the next stages of your calculation, because if you don't have the first bit, it stops you from carrying on with the harder part of the question. So you need to have some values to work with. And if the total customer winnings, 7 tickets which end in 00, and then they pay £12 each. So customers won 7 times 12, and because all winning tickets were sold, the tickets ending in 5, all of those must have been sold. So 75, and they all paid to the customer £1.50. And so how much was paid out will be a total of these two values. So using the calculator, 7 times 12 plus 75 multiplied by £1.50 which is £196.50. That's how much money he paid out. Now, it mentions profit of £163. We need to think about what profit means. Profit, in its simplest terms, is money you take in less money paid out. So there's a difference between how much money you bring in and how much money is paid out, or how much money is lost. So what do we know here? We know the profit is 163. So we're not told how much money he makes from tickets, but we have just worked out how much money is paid out. The money he loses is the money he pays out in prizes, which is the £196.50. So we can work out how much money he made by rearranging this equation. So if we take this £196.50, swap the side of it, and swap the sign. Opposite of minus is to add. Then we can calculate how much money was brought in. So that's going to be £163 added to the £196.50. And so for money brought in, we need to add these two values together. 163 plus £196.50. And that tells us that it's £359.50. So the money Thomas takes from all his sales, his money in, must have been £359.50. Okay? So we need to think about how many tickets he sold. So each ticket, it says here, is 50 pence. And so if he made £359.50 in total from selling them, you can calculate how many tickets he must have sold by calculating the total value of the tickets sold divided by the price per ticket. Don't put divide by 50 because it's in pence, so it's divided by 0.50. So this number here we had before, divided by 0.50, tells us that 719 tickets were sold altogether. Now, what it says here is that he sold all the winning tickets and some losing tickets. So all winning tickets well, there are 7 tickets ending in a 0, and there are another 75 which ended in a 5. So the total of the winning tickets is 7 plus 75, which is 82. So 82 were winning tickets. So the number of losing tickets that were sold must have been the other ones. So losing tickets that were sold will therefore be 719 minus 82, which gives us a total of 637. That was a real beast of a question, a massive 6 marker. So the final answer, 637. So all of that working, lots of hard work. The final answer, 637 losing tickets were sold. Question 26, we've got 2 column vectors, f and g, and we're asked to work out 3f minus 2g. The first thing we need to realise with column vectors is they are relatively easy if you just take them one number at a time. 3f means 3 times f. And 2g means 2 lots of the vector g. And so what we're going to do is just take each one and multiply each number in it separately. And so f is 4 and 5. So if we multiply each number by 3, f is 4 at the top, so 4 times 3 is 12, 5 times 3 is 15. And so 3f is 12 and 15. And from that, we're going to take away 2g. So we compare what g is, and we're going to double each number. So g is 5 at the top, multiply that by 2, we'd get 10. And at the bottom we've got minus 2. Well, if we double 2 it would be 4, but because it was a minus 2, that'll make it minus 4. And so 2g, if we double g, we'd have this vector here. Now what we need to do is, again, just take the top numbers separately to the bottom, and do the top take away the top, the bottom take away the bottom. So the top numbers are 12 and 10. So we're doing 12 minus 10. 12 minus 10 would become 2. But the bottom numbers, we start with 15, and we're subtracting from 15 minus 4. So if we just section this off and just inspect it a bit closer, we're minusing a minus. The two minus signs are next to each other, nearly touching, with nothing between them. Minus a minus number makes it become a positive. So two minuses are a plus. So it's the same as 15 plus 4, which is 19. And so the vector 3f minus 2g would be 2 and 19. Question 27. Work out 280 as a product of its prime factors. So what we do with prime factor factorisation is we start with the number at the top and see what we can divide it by. You can divide it by anything as long as it's not 1. So the smallest thing you can divide it by is 2. So as long as you divide it by 2 or above, it doesn't matter. So we can divide it by 2 actually. We've got a calculator, so let's use it to its potential. So 280 divided by 2. I'd be hoping it's 140. Now what we do with prime factor factorisation is whenever you find a number which is prime, we circle it and don't touch it again. So we leave that 2 and carry on with the other number which isn't prime. The number always branches into 2. On one hand, what you're dividing it by, on the other side, the answer to what that would be. So again, we can divide this one by 2, which would be 70. Circle the 2, because 2 is prime. 70 isn't prime, yet again, because it's an even number, we can half 70, which becomes 35. And I'm inviting you to try your calculator if you're not comfortable doing the division without checking. If in doubt, always check if it's a calculator paper. Finally, 35 isn't even, so we can't divide it by 2, but we can divide it by 5, which would give us 7. Now 5 and 7 are both prime numbers, and so we've done now, because each end of the branching has got a prime at the end of it. So the final answer is we write down all the primes in order of size multiplied by each other. So it's 2 times 2 times 2 times 5 times 7. But what I want you to get into the habit of is writing this in power form. By power form, I mean replace the numbers with powers if possible. 2 times 2 times 2 we can write as 2 cubed times 5 times 7. And so that's the final prime factorisation. I'm going to give you a little tip though here. In fact, it's a rather big tip. You can check that this is right. The calculator is more useful than what you might know. So what we can do is press 280 in the calculator, press equals, then we can find the prime factorisation of this directly by pressing shift and then this button here which has got fact above it. Fact stands for factorisation. So 280, then press fact, and look what we have. So the calculator can do it for you. 2 cubed times 5 times 7. So if I were a gambling man, which I'm not, I'd be saying these questions are very unlikely to come up on a calculator paper, but if they do, and you remember this little trick, then there's no excuse for not finding this question anything other than incredibly straightforward. So just to show you again, type in the number, press equals, and shift, fact, and we're done. Question 28. Expand and simplify y plus 5, y minus 4. What I'm going to do for this one, I'm going to section off the brackets into one row and one column each. So y plus 5 we can write either above or to the side. So I'm going to write this one above. The other bracket we can write down here. So it's a 2 by 2 grid. We're going to end up with 4 different things. So what we're going to do is multiply each thing by what's above the box and what's to the left of the box. So here, the first box is y times y, which is y squared. This one, y multiplied by 5, gives us 5y. Y multiplied by 4 would be 4y. But because this 4 is a minus, that would make it minus 4y. And finally, positive multiplied by a negative, if we're multiplying numbers together and the signs are different, the answer will end up being a negative value. So positive 5 multiplied by negative 4 will give us minus 20. We now need to simplify these bits here. So we've actually got 3 different things to consider. The first thing we've got is the y squareds. The second thing is the normal y's without a 2 on the head. So you can't combine these with y squareds because a normal y is a different beast to a y squared. Finally, we've got the number, which is minus 20. So grouping these bits together, we can see we've got 1y squared. Now altogether, the y's, if you want to, you can include a plus sign in front of that 5y because it's positive. So we've got 5y's over here, a positive 5y, minus 4y from that, we'd still be left with 1y. 5 is a bigger value than 4, so the positive thing is a greater magnitude than the negative thing. So positive will win, if you like. Plus 5 minus 4 will be plus 1y. But because it's just plus 1y, we don't need to include the 1. A y on its own means 1y. So we've got plus y. And finally, just the minus 20. So that's the fully simplified answer. We have y squared plus y minus 20. Question 29. Work out the size of angle x. Alarm bells should be ringing. It's a right-angled triangle. You want to work out an angle. It's going to be trigonometry. It's absolutely going to be a trigonometry question. If we knew those 2 sides like we do, and we wanted to find the third side, that would be Pythagoras. But if we're finding an angle with a right-angled triangle, it's going to be a trig question. And what you need to know almost straight away is SOHCAHTOA. You need to just know that saying offhand, SOHCAHTOA. So what we need to do is to label each side of a triangle. The side opposite to the angle is called the opposite side. So I'm going to call that O for opposite. The longest side is always a side which is opposite to the right angle. Normally you can tell it just by looking at the triangle which side looks the longest, but if ever you're not sure, that's how you can always know. And the longest side is called the hypotenuse, which is H. If the side isn't the opposite or the hypotenuse, the other one's called the adjacent. So find the O first, then the H, the other side will have to be the A. So what I want you to do now is to tick the sides you know. So we know H and we know A. We don't know the opposite, but we're not asked to find the opposite either, so we don't really care about that. So have a look at the triangles, the SOHCAHTOA magic triangles, and highlight the ones which include the H. We know H, so highlight this. Also highlight A, because you know A as well. Which triangle is most colourful? Which triangle do we know most information for? It's the K triangle. What you need to know when you're finding angles, it's always going to be either using the sin -1 button, cos -1, or tan -1. If ever you're finding angles, and only if you're finding angles, use these buttons here where it's a -1 for sin, or cos -1, or tan -1. C stands for cos, and we've chosen to use the cos triangle, and so we're going to be using the cos -1 button on our triangle. We want to find out the angle, so we cover up the C for cos. So cover that up entirely. And whatever's left tells us what to do. So we've covered up the C, which in this case will mean cos -1. We've got A on top and H on the bottom. So A is the adjacent side, which is 8. H means hypotenuse, which goes on the bottom, so we put 11 at the bottom. A on top, H on the bottom. 8 on top, 11 on the bottom. So now we just type this into our calculator carefully, just like this, and it will work. So shift cos to get the cos -1 function. Press fraction. You want 8 on the top and 11 on the bottom. Close the bracket off, press equals, we get 43.3 degrees. So angle X is 43.3 degrees. Part B, again, is a trig question. So yet again, SOHCAHTOA. It's always going to be SOHCAHTOA. So this one over here. There we go. Work out length y. Yet again, always just begin with labelling the sides of a triangle. Opposite the angle is the opposite. And so y is on the opposite side. Opposite to the right angle, that's always going to be the opposite side. Opposite to right angle, sorry, that's the hypotenuse. The longest side is labelled H for hypotenuse. And the other side must therefore be the A for adjacent. So let's tick the sides we know and the side we want to know. So always tick what we're interested in. So tick the side you know and the side you want to know. That's all you need to do when finding a length with trigonometry. Tick the side you know and the side you want to know. Based on the ones you've ticked, so we've ticked the A because we know the A. So highlight the A in these triangles. We've also ticked the O side because we're interested in working out the O side, which is Y. So highlight O in each one of these SOHCAHTOA triangles. And like we did in part A, pick the triangle which includes most information. This one has only got one bit. We only highlighted one bit here, but we highlighted 2 bits for TOA. So we're going to use the TOA triangle. So now we need to think, well, which one do we want to work out? We're working out the opposite side. Y equals the opposite side. Because we want to work out the opposite, we cover up the opposite and see what's left. what's left is t and a next to each other. Two things next to each other in algebra means one multiplied by the other. Now t, c and s, when we're finding lengths of side, always stands for that thing followed by the angle we're talking about. So it doesn't just mean tan, t means tan of the angle in question, which should be 40. So if we were finding a different side, it'd be sin 40. If it were c, it'd be cos of 40. And we multiply that by the adjacent side, which is 37. So we do tan of 40, close the bracket off, multiplied by 37, and to a suitable, sensible accuracy, we can say it's 31, or we could even say 31.0 to 1 decimal place. So altogether that was a 4-mark question for trigonometry. So if they do come up, they're well worth knowing. Nearly at the end now, question 30. A water tank is a cylinder with radius 40 centimetres and a depth of 150 centimetres. It's filled at the rate of 0.2 litres per second. We're also told that 1 litre equals 1000 cm cubed. Now the fact that we're using cm cubed, that's a big clue that we're going to have to be thinking of volume, because cm cubed is a measure of volume. So if I just copy down this conversion here, 1 litre equals 1000 cm cubed. Like we've seen before in this paper, we've got a relationship here where one number is a 1 and the other number isn't a 1. And so what this means is, to go from one to the other, we need to either multiply or divide by 1000. So if we're moving from litres to cubic centimetres, we're going from a small number to a big number, so we're going to be multiplying by 1000. Remember, if one of the numbers is 1 and the other number in the conversion relationship isn't 1, it's always a case of multiplying or dividing by the number that isn't the 1. That means if we go the other way around, from cm cubed to litres, we go the opposite way and do the opposite thing. That would be dividing by 1000 to change from cubic centimetres to litres. Just returning to what I said earlier, it is a big clue that we're going to have to calculate the volume of this cylinder. And so the volume of a cylinder has a formula. A cylinder is actually a type of prism because it's got the same shape running all the way through it. It's circular at the top, it's circular at the bottom, it's circular all the way through no matter where you'd cut it. So the volume of a cylinder is the area of the section of it which is always constant, which is the circle. So it's the area of the circular end multiplied by the length normally, but because it's stood up we can think of this in terms of the height. So we need two things for working out the volume. We need the area of the circular end. The circular end is this shape here. Multiply that by the height, which unfortunately we've been told that's 150. So how do we calculate the area of a circle? Now the area of a circle, the formula, is pi r squared. That's what we just need to remember. So pi is a number which is on our calculator, about 3.14. R stands for radius, which is the length from the middle of a circle to the edge. So the radius is this distance here. Again, luckily been told from the middle to the edge is 40. And so the radius of this circle is 40. So the area of a circular end is pi multiplied by the radius squared Oops, keep doing the wrong colour. And that's going to be multiplied by the height of the cylinder, which again, as I mentioned, we've been told that's 150. So if we just let the calculator do the legwork and do these calculations for us, the volume is pi. To get pi, it's on this calculator at least, it's shift pi multiplied by 40 squared. Then I'm going to multiply that by the height as well. That gives us 240,000 pi. We don't want the answer in terms of pi, so we can convert to an actual real number here. So that's 753,982. Only round at the end of calculations, I'd suggest, because if you round too soon, some rounding error can creep in. So that was 2369. So the units we used, 40 was centimetres, 150 was centimetres. So if centimetres go into our calculation, something involving centimetres will inevitably pop out. So that huge number there is the volume of this cylinder in cubic centimetres. But for questions relating to filling it with water and is mentioning litres, and we've got here a rate of it being filled in litres. So what we need to do, using this relationship we did earlier at the top, is change from cubic centimetres into litres. And to do that, from centimetres to litres, we need to divide by 1,000. So if we take the number we've just worked out and divide by 1,000, that would tell us that in litres, the volume is very roughly, because it's so close, about 754 litres. To the nearest litre at least. But here what we need to do is compare the actual volume of a cylinder, how much it can hold, its capacity, to what it's being filled up with. So it's being filled at 0.2 litres per second. So in a minute, how full would it be? If it's going in at 0.2 litres per second, there's 60 seconds in a minute. So in a full minute, 0.2 times 60. That wouldn't be 30, what am I thinking? 0.2 times 60. Apologies, had a mind blank there, it'd be 12. Goes to show though, I'm definitely not perfect at maths. So if in doubt, if you have a daydream, just always double check with a calculator. 0.2 multiplied by 60, which would be 12 litres a minute. So then in an hour's got 60 minutes. So 12 times 60, 12 times 60 would be 720 litres. So after an hour of filling this tank, after 1 hour, we would have filled up 720 litres. But the total capacity of this cylindrical water tank is 754. And so when it says, does it take longer than 1 hour to fill the tank? Yes, it would. Because after 1 hour, only 720 litres have gone in. But to completely fill it would take 754 litres. So we need all this working to back us up when we say no. Damn. Not a good day today for me. Does it take longer to fill the tank? Yes, it would. Terrible, embarrassing mistakes, but I'm going to leave them in. So 1 hour is not enough time. So I got there at the end. Hopefully I'll make fewer mistakes on question 31, but at least I spotted them in time. 1 hour is not enough time. Yes, it would take longer than 1 hour. So, question 31, the very last question on the entire paper. The value of a second-hand car is £8,000, and we're told that each year it loses 20% of its value at the start of that year. We need to work out its value in 5 years' time. So I'm going to show you two different methods of this one. One is slow but sure. The second method after I'm going to show you this one is much quicker but slightly harder to perhaps understand. It's a harder concept, but it's one I'll try and explain as best I can. So I've just revealed a table of values here. And so the key bit of information here is that it loses 20% of its value at the start of each year. So after 1 year, it'll lose 20% of its value than what it had at the start. So it's going to lose 20% of its initial value. So first of all, 20% of £8,000 we can work out on the calculator. 20% means 20 out of 100. So just typing it into the calculator as a fraction, because percentage means out of 100. 20% of 8,000 gives us £1,600. That's what it loses. It doesn't become 20% of its value, it loses it. And so what we need to do is subtract what's lost from what the initial value for that year was. So it was £8,000. Now we take away 1,600, and what we'd have at the end of the first year is it would be £6,400. So of the second year, the start value for year 2 would be 6,400. So we need to find 20% of that. And so what we need to do is to find 20% of 6,400. Which in the same way, just different numbers, 20% of 6,400 is 20 over 100. Keep pressing an extra 0 for some reason. Multiplied by 6,400, and that will come to 1,280. So after 2 years, the value will be 6,400 minus 1,280, which is 5,120. So as repetitive as this method is, it will get you there slowly but surely. So now the next year is the third year. So at the beginning of the third year, it will be worth what it was at the end of the second year, so it's 5,120. So it'll lose 20% of that value next. 20% of 5,120. Again, if we type this into the calculator, we get £1,024. So that's the value it loses in year 3. So it was 5,120 at the beginning of that year. So we then take away 1,024 and see what's left. What you should find is that it's 4,096. So this subtracted from 1,024, 4,096. Same deal again for year 4. We're getting there. Admittedly quite slowly, but stick with it. Now we're finding 20% of the value at the end of year 3. So 20% of 4,096. So, yet again, 20 over 100 multiplied by 4,096 gives us £819.20. So we subtract this figure from the 4,096. So 4,096 subtract £819.20 is £3,276.80. So that's after 4 years what it's worth. So after 5 years we've finally got to the last line. Hooray! Now we do 20% of £3,276.80. So yet again, 20%, 20 over 100, multiplied by 3276.80. That gives us £655.36. And the final step is £3,276.80 minus the value it loses in this final year. So 3276.80 minus 655.36. Our final total, £2,621.44. That's our final answer. But I did mention I've got another way which is slightly quicker. I'll say slightly, I mean lots quicker. So another way of thinking about it is we always start off with 100% of a value. And so if each year it loses 20%, we need to think what percentage of itself would we have. If you lose 20%, that means 80% still remains. So each year, at the end of each year, it becomes 80% of its former self. And so we need to find 80% of the value of the car each year. And so what we could do to find 80% is we could multiply by 80 over 100. But a quick way of doing that would be to use this decimal multiply method. 80% as a decimal, 80%, think about 80 pence. 100 pennies in a pound, 100% in a full thing. So the percentages works in the same way as pennies. So that's for 1 year. Then after 2 years, it'd be this. times another 0.80. For the third year, times 0.80. So we're actually going to be multiplying by 0.80 a total of 5 times. That's the concept. Each year it becomes 80% of its former self. So year 1, year 2, year 3, year 4, year 5. And so what we can do is actually do this even quicker, because we're multiplying by 0.80 5 times. Something multiplied by itself 5 times we can say is to the power 5. So we can do this in one quick calculation. So what we need to do is 8,000 multiplied by 0.80 to the power 5. Now isn't that much quicker? £2,621.44, like before. And that completes the paper. So I hope you found some of those questions at least useful. Anything you're still struggling with, do feel free to drop a comment or ask your teacher in class. Thank you very much for listening.